Now, in this lecture, we'll find out the area of the circle. In the drawing, we have quadrilateral ABCD. Inside this quadrilateral, we have this circle. In addition, we know that side AB of this quadrilateral equals to 2 units in its length. Side BC equals to 8 units. Side DC also equals to 8 units. Again, our mission is to find out the area of this circle. So, first of all, we'll do a construction. That is to say, we'll extend side DA and side CD of this quadrilateral until they touch each other. This is their touching point. We define the touching point as point M. We define this angle as angle theta. Actually, by doing this construction, we created the right big triangle, triangle TCM. In the right big triangle TCM, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. Why? Because 90 degrees minus theta plus theta it is equals to 90 degrees, and 90 degrees plus 90 degrees it is equals to 180 degrees. That is the sum of the angles in any triangle. Okay. So here, side BC, this side BC or line segment BC is one side of quadrilateral ABCD. Therefore, it is absolutely a straight line. And when we extended this side BC by a straight line, the result is CM. When you extend the straight line by a straight line, the result must be a straight line. Therefore, CM is a straight line. So if we focus on the upper side of this straight line CM at point B, here the sum of the angles must be equal to 180 degrees. According to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. For each angles we have at the upper side of CM at point B, we have this angle is equal to 90 degrees plus the missing angle, that is actually angle ABM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle here must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of the straight line CM at point B to 180 degrees, the missing angle here must be equal to 90 degrees. So in the next step, we'll focus on the small right triangle MBA. In this small right triangle MBA, this angle equals to theta, this angle equals to 90 degrees. Therefore, the missing angle here must be equal to 90 degrees minus theta. According to the same rule that the sum of the angles in a triangle is equal to 180 degrees. In the next step, we'll prove that the right big triangle DCM is similar to the right small triangle MDA. Triangle MBA. Okay, so write it down. So the right triangle DCM is similar to the right small triangle, triangle MBA. The small right triangle MBA. So, why those two right triangles are similar to each other? First of all, those two angles they are both equal to 90 degrees, therefore they are equal to each other. So actually this is angle DCM, in the right big triangle DCM. And it is equal to this angle, that is actually angle ABM, in the right small triangle MBA. Repeat again. Angle DCM in the right big triangle DCM equals to angle ABM in the right small triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles. So we can write down that angle theta equals to itself is a common angle that belongs to both triangles. So if we relate to this angle, angle theta, as it is belongs to the big right triangle DCM, it will be defined as angle DMC. And it equals to itself. So if we define angle theta, if we relate to angle theta as it belongs to the small right triangle MBA, it will be called angle AMB. Again, this equation means that angle theta equals to itself. We just call two angle theta two different names. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles they are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually this is angle MDC. In the right big triangle DCM, it is equals to this angle, it is actually angle MAB. In the small right triangle, triangle MBA. Repeat again. Angle MDC in the big right triangle DCM equals to angle MAB in the small right triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually prove that all the three angles in the right big triangle DCM are correspondingly equal to all the three angles in the right small triangle MBA. Therefore, those two right triangles are convergent to each other according to angle similarity rule. So I write it down. The right big triangle DCM is similar. This is the sign of similar to the right small triangle MBA, according to angle similarity rule. And for the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. We derive that side DC in the big right triangle DCM over side AB in the small right triangle MBA equals to side CM in the big right triangle DCM over side BM in the small right triangle MBA. Repeat again. We derive that DC over AB equals to CM over BM. DC equals to 8 units in its length over AB. AB equals to 2 units in its length, and it is equals to CM. What is the length of this side CM? From the drawing it is very easy to see that CM in total equals to CB plus BM. That is to say, CM equals to CB, that is 8, plus BM. So in total, CM equals to 8 plus BM. So substitute CM, this equation by 8 plus BM divided by BM. So we found out that 8 over 2 equals to 8 plus BM over BM. 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we multiply this equation by BM, and we get that 4 times BM equals to 8 plus BM. Here we subtract BM from this equation, and we get that 4BM minus BM is 3BM, that equals to 8. Here we divide this equation by 3, and finally we get that the missing side BM equals to 8 over 3 units in its length. Here, this side BM equals to 8 over 3 units in its length. In the next step, we focus on this small right triangle MBA, and we'll implement the Pythagoras theorem in this right triangle MBA. Here, by PT is abbreviation for Pythagoras theorem. According to the Pythagoras theorem, in any right triangle, the square of the hypotenuse equals to the sums of the squares of the perpendiculars. The hypotenuse in the right triangle MBA is AM, therefore the square of the hypotenuse is AM squared. And it must be equal to AB squared plus BM squared. Repeat again, in the small right triangle MBA, according to the Pythagoras theorem, AM squared equals to AB squared plus BM squared. So AM squared, that is the square of the hypotenuse, equals to AB squared. AB is 2, therefore AB squared is 2 squared, this is 4, plus BM squared. BM is 8 over 3, therefore BM squared is 8 over 3 squared, that is 64 over 9. And we found out that AM squared equals to 4 plus 64 over 9. So AM squared equals to, here we have 4 plus 64 over 9. We multiply 4 by 9 and then we will divide it by 9 in order to become a factor of 64 over 9. 4 times 9 is 36, so in total, in the numerator of this expression, we will have 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. So if we found out that AM squared equals to 100 over 9. Here we take a root out of this equation, and finally we get that AM equals to the square root of 100 over 9. The square root of 100 over 9 is the square root of 100, that is 10, over the square root of 9, that is 3. So in conclusion, we found out that the length of the hypotenuse AM is actually equals to 10 over 3 units. So write it down in the original drawing that the length of this hypotenuse AM in the right triangle MBM equals to 10 over 3 units. In the next step, we'll do another construction, that is to say, we'll draw perpendicular on side BC in such a way that the perpendicular on BC will be also tangent to this circle. Okay, it is absolutely possible to do it because we have infinite points on BC that we can draw the perpendicular. We choose exactly the point that is also will be perpendicular to the circle, so it is possible to do it. So first of all, this angle equals to 90 degrees, and this angle also equals to 90 degrees according to our construction. We define the touching point of the perpendicular inside BC as point T. We define the point of tendency of the perpendicular and this circle as point K. In the next step, we'll extend the perpendicular TK by a straight line until it touches side AD. We define the touching point of the extended perpendicular TK with side AD as point L. By doing this construction, we created the right middle triangle, triangle MTL. In this right middle triangle, triangle MTL, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. In the next step, we define the center of this circle as point O. We will define the point of tendency of tangent BT if this circle is point N. And finally, we will define the point of tendency of tangent AB with this circle as point H. We join points O and N together by straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON, line segment ON, is the radius of this circle. We define the radius of this circle as x, therefore ON equals to x, it is the radius of the circle. Here we can implement rule 1. I'll repeat quickly rule 1. According to rule 1, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. Again, a tangent to the circle is perpendicular to the radius drawn to its point of tendency. So in the drawing we have a circle and also tangent AB that is tangent to this circle at point M. Point M is the point of tendency. And we have the radius OM that is drawn to point M, that is the point of tendency of tangent AB with this circle. And whenever you have a radius that is drawn to the point of tendency, like in our drawing, then tangent AB will be perpendicular to the radius MO. If AB is perpendicular to MO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees according to this rule, rule 1. You can actually implement rule 1 in our drawing. Why? Because in our drawing we have the radius ON that is drawn to point N, that is the point of tendency of tangent BT with this circle. And whenever you have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius NO. If BT is perpendicular to NO, it means that this angle equals to 90 degrees and this angle is equals to 90 degrees. Only to rule 1. Likewise, we join points O and H together by straight line. Line segment OH is the radius of this circle that's equal to x, according to our definition. The radius OH is drawn to point H, therefore, according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. Likewise, we join points O and K together by a straight line. Line segment KO is drawn. First of all, line segment KO is the radius of this circle is equal to x. The radius OK is drawn to point K, that is the point obtain this, you obtain LT with this circle, and therefore according to rule 1, this angle equals to 90 degrees, and this angle also equals to 90 degrees. In the next step, we will focus on this quadrilateral, this small quadrilateral edge OBN. Inside this small quadrilateral edge OBN, we have 1, 2, 3 right angles. The sum of 3 right angles is 270 degrees, plus the size of the fourth angle. In total, they must be equal to 360 degrees according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Therefore, the missing angle here must be equal to 90 degrees in its size. In order to complete the sum of the angles inside quadrilateral edge OBN to 360 degrees, the missing angle here must be equal to 90 degrees. So inside this small quadrilateral edge OBN, we have 4 right angles. Therefore, quadrilateral edge OBN must be at least a rectangle, if not a square. So we relate to this quadrilateral as a rectangle. And you also note that the opposite sides of a rectangle are equal to each other. That is to say, side edge O must be equal to side BN in this rectangle. But edge O equals to x, therefore BN must be also equal to x. Likewise, according to the same rule, in rectangle edge OBN, this rectangle, side ON must be equal to side HB. But ON equals to x, therefore HB must be also equal to x. So actually found out that quadrilateral edge OBN is not a rectangle but a square because all of its sides are equal to each other. We repeat on the same process in this small quadrilateral OK and B. In this small quadrilateral we have 1, 2, 3 right angles. Therefore the fourth angle must be also equal to 90 degrees. So quadrilateral OK and B is quadrilateral OK and T is 4 right angles. Therefore we relate to this quadrilateral as a rectangle. And you also know that the opposite sides of a rectangle are equal to each other. That is to say, side OK must be equal to side NT. But OK is x, therefore NT must be also equal to x. Likewise, according to the same rule, side ON must be equal to the opposite side KT. But ON is x, therefore KT must be also equal to x. So actually found out that quadrilateral OKNT is also a square. In conclusion, we can say here that side BT in total equals to x plus x, that is 2x. So BT equals to 2x units in its length. BT equals to 2x units in its length. In the next step, we will prove that the right middle triangle LTM is similar to the right small triangle MBA. So I write it down. The right middle triangle LTM is similar to the right small triangle MBA. So why the middle triangle is similar to the small triangle MBA? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. So actually this is angle LTM. In the middle triangle LTM, and it is equal to this angle, that is actually angle ABM, in the right small triangle MBA. Repeat again. angle LTM in the right small triangle LTM equals to angle LTM in the middle triangle LTM equals to angle ABM in the right small triangle MBA. They are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta. That is a common angle. It belongs to both triangles. So we can write down that angle theta equals to itself as a common angle that belongs to both triangles. So if we relate to this angle theta, as it belongs to the middle triangle LTM, it will be defined as angle LMT. And it equals to itself. So if we relate to angle theta as it belongs to the right small triangle MBA, it will be called angle AMB. Angle LMT in the middle triangle LTM equals to angle AMB in the small right triangle MBA. They are both actually equal to theta. In this equation, we actually called to angle theta two different names. This equation means that angle theta equals to itself. We just call to angle theta two different names. Angle theta equals to itself is a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So actually, this is angle MLT. In the middle right triangle LTM, and it is equals to this angle. It's actually angle MAB in the right small triangle MBA. Repeat again. Angle MLT in the right middle triangle LTM equals to angle MAB in the right small triangle MBA. They are both equal to 90 degrees minus theta, therefore they are equal to each other. So we should prove that all the three angles in the right mid triangle LTM, in the right middle triangle LTM, are correspondingly equal to all the three angles in the right small triangle MBA. Therefore, we proved that the middle triangle LTM is similar to the right small triangle MBA according to angle similarity rule. So I write it down. Actually proved that the right middle triangle LTM is similar to the right middle triangle MBA according to angle similarity rule. And from the fact that the middle triangle is similar to the one small triangle, we derive that the following relationship exists between their sides. We derive that side LT in the middle triangle LTM, or side AB in the right small triangle MBA, equals to side TM in the right middle triangle LTM over side BM in the right small triangle MPA. Repeat again. We derive that LT over AB equals to TM over BM, and it is also equals to side LM in the right middle triangle LTM over side AM in the right small triangle MBA. So we can found out that LT over AB equals to TM over BM, and it is also equals to LM over AM. Okay, so here we have side LT. Side LT is the missing side, so we leave it as it is. Over AB. AB is 2, therefore we substitute AB by 2. And it is equal to side TM. What is the length of TM? From the drawing it is very easy to see that TM in total equals to TB plus BM. That is to say TM equals to TB, that is 2x, plus BM, that is 8 over 3. So in total TM equals to 2x plus 8 over 3. So we substitute TM by 2x plus 8 over 3 divided by BM. BM equals to 8 over 3. So we substitute BM by 8 over 3. And it is also equals to LM. What is the length of LM? LM equals to LA plus AM. That is to say, LM in total equals to LA, this is the missing side, plus AM, that is 10 over 3. So in total, LM equals to LA plus 10 over 3. So we substitute LM in this equation by LA plus 10 over 3 divided by AM. AM is 10 over 3. So we substitute AM in this equation by 10 over 3. So we have this normal equation. Those two sides are equal to each other, so we get the equation 1 from those two sides that are equal to each other. So according to the first equation, equation 1, LT over 2 equals to 2x plus 8 over 3 over 8 over 3. Okay, so according to equation 1, LT over 2 equals to, in this side of the equation we have 2x plus 8 over 3. Here we multiply 2x by 3 and then we divide it by 3 in order to overcome factor with 8 over 3. So 2x times 3 is 6x, so in total in the numerator of this expression we will have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. So in this side of the equation 1 we have 3 in the numerator and 3 in the denominator, so 3 get cancelled. So what is left from equation 1 after we cancel 3? This side of the equation we have LT over 2 equals to, in the other side of the equation we left only with 6x plus 8 over 8. So here we cross multiply this equation 1, and we get that according to equation 1, 8 times LT equals to 2 times 6x plus 8. Here we divide this equation 1 by 2, and we get that 8 over 2 is 4, so in total, in this side of the equation, we have 4LT. That's equals to, on the other side of the equation, we have 2 over 2 is 1, so we're left only with 6x plus 8. Here we divide this equation by 4, and finally we get that LT, the length of line segment LT, is actually equals to 6x over 4 is 1.5x, plus 8 over 4 is 2. So in conclusion, we found out that LT equals to 2 plus 1.5x. So I write it down. Here, this line segment LT or side LT equals to 2 plus 1.5x. We continue to focus on the long equation that we created here. This is the long equation that we created. In this long equation, those two sides they are equal to each other. Therefore, we create equation 2 from those two sides that are equal to each other. So according to equation 2, we get that 2x plus 8 over 3 over 8 over 3 equals to LA plus 10 over 3 over 10 over 3. Again, according to the second equation or equation 2, we found out that 2x plus 8 over 3 over 8 over 3 equals to LA plus 10 over 3 over 10 over 3. So we have here 2x plus 8 over 3. We'll multiply 2x by 3, then we'll divide it by 3 in order to overcome a factor with 8 over 3. So 2x times 3 is 6x. So in total, in the numerator of this expression, we'll have 6x plus 8 divided by 3, and then we have also to divide it by 8 over 3. And it is equals to, here we have, on the other side of the equation, we have LA plus 10 over 3. Here we multiply LA by 3 and then we divide it by 3 in order to overcome a factor with 10 over 3. LA times 3 is 3LA. So in total, in the numerator of this expression, we'll have 3LA plus 10 divided by 3, and we have to divide it also by 10 over 3. So in this side of this equation 2, we have 3 in the numerator and 3 in the denominator, so 3 get cancelled. In the other side of this equation 2, we have also 3 in the numerator and 3 in the denominator, so 3 also get cancelled. So what is left from this equation 2 after we cancelled 3 from both sides of the equation? Actually, in this side of the equation, we have only with 6x plus 8 over 8, and it equals, in the other side of the equation, we left only with 3LA plus 10 over 10. Okay, so here we of course multiply this equation 2, and we get that according to equation 2, 10 times 6x plus 8 equals to 8 times 3LA plus 10. So here we will divide this equation 2 by 2, and we get that according to equation 2, we have here 10 over 2 is 5. Inside the brackets we have 6x plus 8 equals to, here we have 8 over 2 is 4. Inside the brackets we have 3LA plus 10. So here we'll open the brackets on both sides of this equation 2. And you get that according to equation 2, 5 times 6x is 30x, plus 5 times 8 is 40, and it is equals to 4 times 3LA is 12LA, plus 4 times 10 is 40, so it is plus 40. So here we have 40 on both sides of the equation, so 40 will get cancelled, and we're left only with 30x, that is equals to 12LA. So here we divide this equation 2 by 12, and finally we will get that LA equals to 30x over 12, that is 2.5x. LA equals to 2.5x in its length. So the line here in the drawing itself, that the length of this line segment LA is 2.5x. In the next step, I will copy the small quadrilateral ALBT in a new page with the circle that is inscribed inside it, and we'll analyze this quadrilateral ALBT. So actually this is the small quadrilateral ALBT that I copied from the original drawing with the circle that is inscribed inside it. First of all, we define the point of tendency of tangent AL if this circle is K. We define the point of tendency of tangent AB if this circle is M. We define the point of tendency of tangent BT with this circle as N. And finally, we define the point of tendency of tangent LT with this circle as H. Here we can implement rule 2. I'll repeat quickly on rule 2. According to rule 2, the lengths of two tangents from a common external point to a circle are equal. In the drawing we have a circle and also this common external point, point P. From the common external point, point P, we have two tangents to the circle, tangent PA and tangent PB. And according to this rule 2, they are equal to each other. That is, say PA equals to PB. We can actually implement rule 2 in our drawing. Because if we focus on the common external point, point A, this point, from the common external point, point A, we have two tangents to this circle, tangent AM and tangent AK. According to rule 2, they are equal to each other. That is to say, AM equals to AK according to rule 2. So, if we define the length of tangent AK as A, then the length of tangent AM must be also equal to A because they are equal to each other. So concluding found out that AM equals to AK equals to A. Likewise, we focus on the common external point, point B. From the common external point, point B, we have two tangents to the circle, tangent BN and tangent BM, and according to rule 2, they are equal to each other. That is to say, BN equals to BM. BN equals to BM according to the same rule, rule 2. So if we define the length of tangent BM as B, then the length of tangent BN must be also equal to B because they are equal to each other. So in conclusion, we found out that BN equals to BM equals to B. In the next step, we focus on the common external point, point T. Here, from the common external point, point C, we have two tangents to this circle, tangent TH and tangent TN. And according to rule 2, they are equal to each other. That is to say, TH equals to TN. According to the same rule, rule 2. So if we define the length of tangent TH as C, then the length of tangent TN must be also equal to C because they are equal to each other. So in conclusion, we found out that TH equals to TN equals to C. And finally, we will focus on the common external point, point L. For the common external point, point L, we have two tangents to this circle, tangent LK and tangent LH. And according to rule 2, they are equal to each other. That is to say, LK equals to LH according to the same rule, rule 2. So, if we define the length if we define the length of tangent LK as D, then the length of tangent LH must be also equal to D because they are equal to each other. So in conclusion, we found out that LK equals to LH equals to D. Okay, so in the next step, we will add side AB to side LT. This quadrilateral ALBT. Again, what is the value of side AB plus the opposite side, side LT? From the drawings, it's very easy to see that AB equals to A plus B and LT equals to C plus D. So in total, AB plus LT equals to A plus B plus C plus D. Likewise, we'll add the side AL to the opposite side, side BT. So what is the value of AL plus BT? From the drawing, it is very easy to see that AL plus BT in total equals to A plus B plus C plus D. Again, AL plus BT equals to A plus B plus C plus D. So can I here that AL plus BT also equals to A plus B plus C plus D. So those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. So if we can write down that the expression AB plus LT equals to the expression AL plus BT. Okay, again, if we found out that AB plus LT equals to AL plus BT. It is given us the question that the length of side AB is 2, so we substitute AB by 2 plus LT. We already found out that LT equals to 2 plus 1.5x. Therefore, we substitute LT in this equation by 2 plus 1.5x. And it is equals to AL plus BT. AL is 2.5x. So we substitute AL in this equation by 2.5x plus BT. Here, line segment BT equals to x plus x. That is to say, BT equals to 2x. So we substitute BT in this equation by 2x. So in conclusion, we found out that 2 plus 2 plus 1.5x equals to 2.5x plus 2x. 2 plus 2 is 4, so in total in this side of the equation we have 4 plus 1.5x. In the other side of the equation we have 2.5x plus 2x is 4.5x. So in conclusion, we found out that 4 plus 1.5x equals to 4.5x. Here we subtract 1.5x from this equation, and finally we get that 4 equals to 4.5x minus 1.5x is 3x. So 4 equals to 3x. Here we divide this equation by 3, and finally we get that x equals to 4 over 3 units in its length. So if we found out that the radius x of this circle equals to 4 over 4 units in its length. Our mission is to find out the area of this circle. We know that the area of any circle equals to pi times the radius of the circle squared. Therefore, the area of our circle will be equal to pi times the radius squared. The radius is x, therefore the radius squared is x squared. So the area of our circle will be equal to pi times x squared. But we just right now found out that x equals to 4 over 3. If x is 4 over 3, it means that x squared is 4 over 3 squared. So it is pi times x squared is 4 over 3 squared. So the area of our circle will be equal to pi times 4 over 3 squared. It is pi times 4 over 3 squared. 4 over 3 squared is 4 over 3 squared is 4 squared, that is 16. Over 3 squared, that is 9. So in conclusion, we found out that the area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, the area of our circle will be equal to 5.585 square units. And that is the answer to our question. Repeat again. The area of this circle equals to either 16 pi over 9 square units, or in terms of numbers, it is equals to 5.585 square units. Okay, so in the next step, I will summarize the lecture. In this lecture, we found out the area of this circle. In the drawing, we have quadrilateral ABCD. Inside this quadrilateral, we have this circle. In addition, we know that side AB equals to 2 units in its length, side BC equals to 8 units in its length, and side DC also equals to 8 units. This is angle ABCD is equal to 90 degrees in its size. This is angle DCA, that is also a right angle. Again, our mission is to find out the area of this circle. So in the first step, we did a construction. That is to say, we extended side DA and side CB of this quadrilateral ABCD by a straight line until they touch each other. So this is their touching point. We define their touching point as point M. By doing this construction, we created the right big triangle DCM. We defined this angle as angle theta, so inside the right big triangle DCM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. 1 equals 90 degrees minus theta plus theta, it is equals to 90 degrees, and 90 degrees plus 90 degrees, it is equals to 180 degrees, that is the sum of the angles in any triangle. Okay, then we actually extended side CB by side line, and the result is side CM, is the line segment CM. When you extend a straight line by straight line, the result must be a straight line. Therefore, CM must be a straight line. So if we focus on the upper side of the straight line CM at point B, here the sum of the angles must be equal to 180 degrees, according to the rule that the sum of the angles in any triangle is equal to 180 degrees. So which angles we have at the upper side of CM at point B? We have this angle that is equal to 90 degrees plus the missing angle that's actually angle ABM. In total, the sum of those two angles must be equal to 180 degrees according to the rule that I mentioned. Therefore, the missing angle must be equal to 90 degrees. In order to complete the sum of the angles on the upper side of CM at point B to 180 degrees, the missing angle must be equal to 90 degrees. And therefore, triangle ABM is a right angle, because this angle is a right angle. So inside the right small triangle LBM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta according to the sum rule that the sum of the angles in any triangle is equal to 180 degrees. Then we proved that the right big triangle DCM is similar to the right small triangle, triangle MBA. So why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, that is a common angle, it belongs to both triangles. So we can write down that angle theta equals to itself, it's a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So we can prove that all the three angles inside the right triangle DCM are correspondingly equal to all the three angles in the small right triangle MBA. Therefore, those two right triangles are similar to each other according to angle similarity rule. And from the fact that those two right triangles are similar to each other, we derive that the following relationship exists between their sides. That side DC in the right big triangle DCM over side AB in the small right triangle MBA equals to side CM in the right big triangle DCM over side BM in the right small triangle MBA. Repeat again. We derive that DC over AB equals to CM over BM. DC equals to 8 units, AB equals to 2, and it is equals to CM over BM. What is the value of CM? From the drawing it is very easy to see that CM in total equals to CB plus BM. That is to say CM equals to CB, that is 8 plus BM. So in total CM equals to 8 plus BM. Therefore, substitute CM here by 8 plus BM, and we have to divide it by BM. So 8 over 2 is 4, so 4 equals to 8 plus BM over BM. Here we multiply this equation by BM, and found out that 4 times BM equals to 8 plus BM. Here we subtracted BM from this equation, and finally found out that 4 times BM minus BM is 3BM, so 3BM equals to 8. Here we divided this equation by 3 and finally found out that BM equals to 8 over 3 in its name. Here, this 9 segment BM or side BM equals to 8 over 3 in its name. Then we focus on this right small triangle MBA. We implemented the Pythagoras theorem on this small right triangle MBM. According to the Pythagoras theorem, AM square equals to AB square plus BM square. Repeat again, in the right small triangle MBM, according to the Pythagoras theorem, AM square equals to AB square plus BM square. So AM squared, that is the square of the hypotenuse, equals to AB squared. AB is 2, therefore AB squared is 2 squared, that is 4, plus BM squared. BM is 8 over 3, therefore BM squared is 8 over 3 squared, that is 64 over 9. So in conclusion, found out that AM squared equals to 4 plus 64 over 9. So here we multiplied 4 by 9 and then we divided by 9 in order to have a common factor with 64 over 9. So 9 times 4 is 36, so in total in the numerator of this expression we will have 36 plus 64 divided by 9. 36 plus 64 is 100 divided by 9. So in conclusion we found out that AM squared equals to 100 over 9. Here we took a root out of this equation and finally found out that AM equals to the square root of 100 over 9. The square root of 100 over 9 is the square root of 100, that is 10, over the square root of 9, that is 3. So in conclusion we found out that the work of the hypotenuse AM is equals to 10 over 3 units. Here the hypotenuse AM equals to 10 over 3 units in its length. Then we did another construction, that is to say, we drew perpendicular on side BC in such a way that the perpendicular on BC will be also tangent to this circle. Okay. So actually this angle equals to 90 degrees and this angle equals to 90 degrees according to our construction. we define the touching point of the perpendicular inside BC as T, and we define the point of tendency of the perpendicular with this circle as K. Then we extended the perpendicular TK by straight line until it touches side AD. We define the touching point of the extended perpendicular TK with side AD as L. By doing this construction, we created the right medial triangle LTM. In the right medial triangle LTM, this angle equals to theta, this angle equals to 90 degrees, therefore the missing angle must be equal to 90 degrees minus theta. Okay, then we define the center of this circle as O, and we added point O and N together by straight line. Point O is the center of the circle, point N is the point of the circle itself, therefore ON is the radius of this circle. We define the radius of this circle as x, therefore ON equals to x because it is the radius of the circle. And we implemented here all 1. According to all 1, we have the radius ON that is drawn to point N, that is the point of tendency of tangent BT with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent BT will be perpendicular to the radius NO. If BT is perpendicular to NO, it means that this angle equals to 90 degrees and this angle also equals to 90 degrees, according to all 1. Then we added point O and H together by straight line. OH is the radius of this circle that is equal to x. The radius OH is drawn to point H, therefore according to all 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Then we added points O and K together by straight line. Line segment OK is the radius of this circle that is equal to x. The radius OK is drawn to point K, therefore according to all 1, this angle equals to 90 degrees and this angle also equals to 90 degrees. Then we focus on the small quadrilateral, this small quadrilateral OK and T. In this small quadrilateral OK and T, we have 1, 2, 3 right angles. Therefore, the fourth angle must be also equal to 90 degrees. According to the rule, that the sum of the angles in any quadrilateral is equal to 360 degrees. So, inside quadrilateral OK and T, we have 4 right angles. Therefore, we can relate to this quadrilateral OK and T as a rectangle. And we also know that the opposite sides of a rectangle are equal to each other. That is to say, side OK equals to side NT. But OK equals to x, therefore NT must be also equal to x. Likewise, according to the same rule that the opposite sides of a rectangle are equal to each other, we get that side ON equals to the opposite side KT in the rectangle OK and T. But ON equals to x, therefore KT must be also equal to x. So actually found out that the quadrilateral OK and T is not a rectangle but a square. Then we repeated the same process here. Inside this small quadrilateral OH BN, we have 1, 2, 3 right angles, therefore the fourth angle must be also equal to 90 degrees. Therefore, this quadrilateral that has 4 right angles must be less rectangle plus a square. We relate to this quadrilateral as a rectangle, and we also know that the opposite sides of a rectangle are equal to each other. That is to say, side OH equals to side BN. But OH is x, therefore BN must be also equal to x. Likewise, according to the sum rule, side ON must be equal to the opposite side HB. But ON equals to x, therefore HB must be also equal to x. Again, we found out that quadrilateral OHBN is not a rectangle but a square. In conclusion, we found out that line segment BT equals to x plus x, that is 2x. Here we can write here that BT equals to 2x units in its length. Then we proved that the right middle triangle LTM is similar to the right small triangle MBA. Why those two right triangles are similar to each other? First of all, those two angles are both equal to 90 degrees, therefore they are equal to each other. In addition, this is angle theta, this is a common angle, it belongs to both triangles, so we can write down that angle theta equals to itself. It's a common angle that belongs to both triangles. And finally, those two angles are both equal to 90 degrees minus theta, therefore they are equal to each other. So, we actually proved that all the three angles of the right middle triangle LTM are correspondingly equal to all the three angles of the right small triangle MBA. Therefore, those two right triangles, the middle triangle and the small triangle, are similar to each other according to angle similarity rule. And from the fact that those two right angles are similar to each other, we derive that the following relationship exists between their sides. We derive that side LT in the big triangle over side AB in the small triangle equals to side TM in the middle triangle over side BM in the small triangle, and side LM in the middle triangle equals to side LM in the middle triangle, and it is equal to side LM in the middle triangle over side AM in the small triangle. Repeat again, we derive that LT over AB equals to TM over BM equals to LM over AM. LT is the missing side, so we leave it as it is, over AB. AB is 2, so we substitute AB by 2. And it is equals to TM over BM. What is the length of TM? From the domain, it is very easy to see that the value of TM, in total, it is equals to 2x plus 8 over 3. So substitute TM here by 2x plus 8 over 3 over BM. BM is 8 over 3, so substitute BM by 8 over 3. And it is equals to LM over AM. LM equals to LA plus AM. That is to say LM equals to LA, that is the missing side, plus AM, that is 10 over 3. So in total, LM equals to LA plus 10 over 3. Here, LM equals to LA plus 10 over 3 divided by AM. AM is 10 over 3, so substitute AM here by 10 over 3. So we created this long equation. In this long equation, those two sides are equal to each other. So we created equation 1 from those two sides that are equal to each other. So according to equation 1, LT over 2 equals to 2x plus 8 over 3 over 8 over 3. So we have in equation 1, LT over 2 equals to, we have here 2x plus 8 over 3. So here we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. So 2x times 3 is 6x. So in total, in the numerator of this expression, we will have 6x over 8 divided by 3, and we have to divide it by 8 over 3. So here we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. After cancelled 3, we left only with LT over 2, that is equals to 6x plus 8 over 8. Here we first multiply this equation 1, and found out that according to equation 1, 8 times LT equals to 2 times 6x plus 8. Here we divided the equation by 2, and found out that 8 over 2 is 4, so in total this side of the equation we have 4LT. This equals to 2 over 2 is 1, so here we left only, in this side of the equation, we left only with 6x plus 8. So in conclusion, we found out that 4LT equals to 6x plus 8. Here we divided this equation by 4. And finally, we found out that LT equals to 6x over 4 is 1.5x, plus 8 over 4 is 2. So in conclusion, we found out that LT equals to 2 plus 1.5x. Here, this nice segment LT equals to 2 plus 1.5x. Then we continue to focus on the long equation that we created. In this long equation, those two sides are equal to each other. Therefore, we created equation 2 from those two sides that are equal to each other. So according to the second equation, this equation 2, we have here 2x plus 8 over 3 over 8 over 3 equals to LA plus 10 over 3 over 10 over 3. So in this side of the equation, we have 2x plus 8 over 3. So we multiply 2x by 3 and then we divide it by 3 in order to have a common factor with 8 over 3. So 2x times 3 is 6x. So in total, in the numerator of this expression, we'll have 6x plus 8 divided by 3, and we have to divide it also by 8 over 3. In the other side of the equation, we have LA plus 10 over 3. So we multiplied LA by 3 and then we divided by 3 in order to overcome the factor with 10 over 3. LA times 3 is 3LA, so in total, in the numerator of this expression, we have 3LA plus 10 divided by 3, and we have also to divide it by 10 over 3. In the side of the equation, we have 3 in the numerator and 3 in the denominator, so 3 will get cancelled. On the other side of the equation, we have also 3 in the numerator and 3 in the denominator, so 3 also will get cancelled. After we cancel 3 on both sides of the equation 2, we have to live with 6x plus 8 over 8 equals to 3LA plus 10 over 10. Here we must multiply this equation 2, and found out that according to equation 2, 10 times 6x plus 8 equals to 8 times 3LA plus 10. Here we divided this equation 2 by 2, and finally found out that 10 over 2 is 5, so inside the brackets we have 6x plus 8. That equals to 8 over 2 is 4, and inside the brackets we have 3LA plus 10. Here we open the brackets on both sides of this equation 2, and found out that 5 times 6x is 30x, plus 5 times 8 is 40, that is equal to 4 times 3LA, that is 12LA, plus 4 times 10, that is 40. So here we have 40 on both sides of the equation, so 40 will get cancelled, and finally found out that what is left after equation 2 after we cancelled 40, what is left is actually 30x, that equals to 12LA. Here we divided the equation by 12, and finally found out that LA equals to 30x over 12, that is 2.5x. So here, this line segment LA equals to 2.5x in its length. Then I copied the quadrilateral LA BT in a new page with the circle that is inscribed inside it, and we analyzed in this quadrilateral LA BT. Actually, we implemented on this quadrilateral with the circle that is inscribed inside it, rule 2. This is quadrilateral ALBT that I copied from the original drawing with the circle that is inscribed inside it. Here we can implement rule 2. If we focus on the common standpoint point A, on the common standpoint point A, we have two tangents to this circle, tangent AK and tangent AM. And according to rule 2, they are equal to each other. That is to say, AK equals to AM. So if we define the length of AK as A, then AM must be also equal to A, because they are equal to each other. So AM equals to AK equals to A. Then we focus on the common standpoint point B. From the common standpoint point B, we have two tangents to this circle, tangent BN and tangent BM. And according to rule 2, they are equal to each other. That is to say, BN equals to BM. So if we define the length of BM as B, then BM must be also equal to B, because they are equal to each other. So in conclusion, we found out that BM equals to BM equals to B. Then we focus on the common standpoint point T. From the common standpoint point T, we have two tangents to this circle, tangent TN, tangent TN and tangent TH. And according to rule 2, they are equal to each other. That is to say, TN equals to TH. So if we define the length of Tn as C, then Th must be also equal to C, because they are equal to each other. So in conclusion, we found out that Tn equals to Th equals to C, and finally we focus on the common standpoint point L. From the common standpoint point L, we have two tangents to this circle, tangent LK and tangent LH. And according to rule 2, they are equal to each other. That is to say, LK equals to LH according to rule 2. So if we define the length of LK as D, then LH must be also equal to D, because they are equal to each other. So in conclusion, we found out that LK equals to LH equals to D. Then we added side AB to side LT. What is the value of AB plus LT? From the drawing, it is very easy to see that AB equals to A plus B and LT equals to C plus D. So in total, AB plus LT equals to A plus B plus C plus D. Likewise, we added side AL to the opposite side, side BT. AL plus BT in total will be equal to A plus B plus C plus D. So AL plus BT also equals to A plus B plus C plus D. So those two expressions, they are both equal to A plus B plus C plus D, therefore they are equal to each other. That is to say AB plus LT equals to AL plus BT. Okay, again. AB plus LT equals to AL plus BT. AB is 2 plus LT. We already found out that this line segment LT equals to 2 plus 1.5x. So substitute LT by 2 plus 1.5x, and it is equal to AL plus BT. It equals to AL. AL is 2.5x. So substitute AL here by 2.5x plus BT. Here BT is 2x. So substitute BT by 2x. Here substitute BT by 2x. So in conclusion, found out that 2 plus 2 plus 1.5x equals to 2.5x plus 2x. 2 plus 2 is 4, so in total in this side of the equation we have 4 plus 1.5x. That is equals to 2.5x plus 2x is 4.5x. So in conclusion, found out that 4 plus 1.5x equals to 4.5x. Here we subtracted 1.5x from this equation and finally found out that 4 equals to 4.5x minus 1.5x is 3x. So 4 equals to 3x. We divided this equation by 3 and finally found out that x equals to 4 over 3 units in its length. The radius x of this circle equals to 4 over 3 units in its length. Again, our mission is to find out the area of this circle. The area of any circle equals to pi times the radius of the circle squared. So the area of our circle will be equal to pi times the radius squared. The radius is x, therefore the radius squared is x squared. So the area of our circle equals to pi x squared. And we just right now found out that x is 4 over 3. If x is 4 over 3, it means that x squared is 4 over 3 squared. Therefore the area of our circle will be equal to pi times 4 over 3 squared. Pi times 4 over 3 squared equals to 4 over 3 squared equals to 4 squared, that is 16, over 3 squared, that is 9. Therefore, the area of our circle will be equal to either 16 pi over 9 square units, or in terms of numbers, the area of this circle will be equal to 5.585 square units. Okay, thank you very much.